Let's start with a new concept called hypothesis testing. And to start with, we're going to look at a situation with a bag of Skittles. Here I have a standard bag of Skittles, and I'm going to open it up and dump out all the contents. Now, I want these Skittles to represent all Skittles possible, and since the easiest way for me to take a random sampling of Skittles is to buy a single bag, that's what I did. If you're wondering why a single bag is an acceptable sample, think of it as a cluster sample. Skittles come together in clusters, and each cluster is a well-mixed sample. It's not just bags of green and bags of purple, things like that. I bought a well-mixed bag of Skittles. So I opened up this large bag of Skittles, and I started sorting out the Skittles by color. The problem I have with Skittles is that I'm not a big fan of yellow, and for some reason I believe that every bag of Skittles comes with too many yellow, and I want to see if I can prove that they give me more than 1/5 of the Skittles being yellow in every bag. So what I'm going to do is I'm going to open one bag and see if there's enough evidence in that one bag to make a statement about all Skittles. And you can see here I'm going to continue to organize these. Stretch ahead, there's my big yellow bar. Count these all up, and eventually you can see that I do in fact in this particular bag have more yellow than everything else. The question is that enough evidence to convince me of anything? Take a step aside from the Skittles for a moment and look at a court of law. There are two things that you can possibly be in a court of law. You can be either innocent or guilty. And we're going to start out with this idea of the null hypothesis and the alternative hypothesis. The null hypothesis is what we start with, what we assume when someone comes in to, in this case, the courtroom. The accused person is assumed to be innocent. And that's not true in all countries, but thankfully we live in a country where that is true. So when you're accused, you're assumed innocent until you can prove the other hypothesis. The other hypothesis, of course, is that you are guilty. So if you have enough evidence to say that the null is not true, if you have enough evidence to prove that someone is not innocent, you have to assume then that they must be guilty. Now let's take that same approach with our Skittles. Our null hypothesis is not the thing that we're trying to prove, it's the default assumption, the thing that you would generally expect. And in this case, we're going to say that let's give them the benefit of the doubt in the null hypothesis that all bags of Skittles come with 20% of each color. And of course, it could be a little bit different because there's randomness involved, but in general, it's 20% for each color. So 20% of Skittles then are going to be yellow, and since we're dealing with proportions, we're going to say P equals 0.2. So the proportion of Skittles that are yellow is 0.2. The alternative then is what we're looking to find. We're trying to say that there are too many yellows, that yellow represents more than 20%. So more than 20% of Skittles are yellow, therefore P is greater than 0.2. Now when we go out and see how likely it is for the null hypothesis to be true, given the actual evidence that we found in our sample, we need to pick a certain threshold value. How likely are we going to tolerate? If something could happen 30% of the time, that seems pretty reasonable. But if something could happen only 5% of the time, that starts to seem so unlikely that I would almost want to reject the null hypothesis. So if it's unlikely enough for the null hypothesis to be true, then I will be convinced that I have to go with the alternative. That's the basic logic of the hypothesis test. So in this case, we're going to choose 5% because that tends to be the standard value that most people choose. And again, what we do with our null is we propose it, and then we try to do something kind of like this. Basically, we're trying to take that null and smash it as much as possible with our evidence from our sample. Thank you, Hulk. We put our data in stat key, and we'll show you how to do this later. But the basic idea is that we're going to assume our null to be true. We're going to assume that the proportion really is 0.2. 20% of Skittles are yellow. If we assume that and we have data kind of like distributed the way we have it, we're going to see some sort of basic bell curve here where a lot of them are 20%, and then it kind of trails off in both directions, where it could be as high as 30%, it could be as high as 35%, but the higher and higher you get up or the lower and lower you get down, the less likely it is to occur. So now we're going to look at the actual data we got. If you count up all those Skittles that we had, there were 27 yellow Skittles out of a total of 108. And that actually represents 25%, 0.25 as a proportion of all the Skittles. So anything that is that high, 0.25 or higher, we are going to look at and consider what probability we have of getting something like that. And all we're really doing here is counting the number of samples that generated something that high out of the total and taking that proportion, that probability. And here, I don't know if you can see that number, but it's 0.117. So that means that 11% of the time, if the null hypothesis was true, we were going to see as many as 27 out of 108 yellow Skittles in a bag. So that means it's actually not all that unlikely to happen. It's not super likely, but 11, almost 12% is a reasonable thing to occur. So thinking back to how we make a conclusion with that kind of data, we're going to say that we don't have enough evidence to prove the null hypothesis wrong beyond a reasonable doubt. It's just like in court. You might have a few witnesses go and testify against someone, but if there's not enough convincing evidence, even though there is some evidence against the person, they're going to let that person go. You can see here, we have some evidence that there are too many yellow Skittles being given to people in their bags of Skittles, but not enough, not beyond a reasonable doubt, such that we can prove it wrong. Now, there's a few different ways that we can get more evidence, such as opening more bags of Skittles, getting more data points. You could also have one bag that has tons and tons of yellow compared to everything else. So there are ways that we will look at later of how to prove our point, but for now we do not have enough evidence. Note that we didn't prove that the null hypothesis is true. We did not prove that there are 20% yellow Skittles. We just failed to find our alternative to be true. We failed to reject the null. It's a weird set of logic, but the thing that we were going out to do, our objective here, was to show that it's so unlikely that there's 20% that there must in fact be more than 20% yellow. We did not prove that there are in fact 20% yellow. That would be a totally different type of hypothesis or different type of situation. So going over a quick recap of what we did. We set up the problem. So we decided to define what we were going to test. We were looking at a proportion, and P represented the proportion of all Skittles that are yellow. So P, proportion of all Skittles that are yellow. And our null hypothesis is that 20% of them, 1/5 of the Skittles, would in fact be yellow. But remember, our goal was to smash that hypothesis. We wanted to, in fact, make it seem so unlikely that we had to go with the alternative that P was greater than 0.2, that the proportion of yellow Skittles was greater than 20%. We decided that the level of convincing evidence for us was going to be 5%, 0.05 probability. If we saw that the null was less than 5% likely to happen, then we were going to reject it. However, we did not. So we went out, we did our data collection. We collected a random sample. In this case, it was a cluster sample, a bag of Skittles. And we counted up the 108 Skittles in the bag. And then we plugged it into the StatKey simulator. And what we found was a p-value of about 12%, just under 12%. So that means there is a 12% chance that we would see data like this if the null were really true. Therefore, that's not enough evidence to say that there's more than 20% yellow Skittles in a bag. So we started with this set of hypotheses, defined our proportion, set the level that we would be convinced, went out, got our data, simulated, and therefore had to conclude that in this case we don't have enough evidence.